It turns out your eye is very much like a camera. Your eye has a number of features like the cameras we've discussed up till now. The retina, at the very back of your eye, has the rods and cones which act like a film or a CCD in a camera. That's the thing that's taking the picture or capturing the light. So when you have an object sitting out in front of your eye, casting rays in a number of different directions, you have a lens at the front of your eye that's collecting that light and focusing an image back at the retina. Notice that the focal length of this lens will be shorter than the diameter of your eye because what we're trying to do in the case of the eye is create the image distance, the distance between the lens and the retina, that matches the diameter of your eye. The key is to have the image distance be equal to that eye diameter. So here's your lens at the front of the eye, and it's trying to create a point of focus, and that creates an image. It's a real image again, just like in the case of the camera, and it's inverted, just like in the case of the camera. There's a focal point to your lens, and it's going to always be a little shorter than the actual eye itself. There are some abnormalities in some folks' eyes, and that is that they are either nearsighted or farsighted. And that has to do with the match of the focal length to where it should be in order to get a good image at the retina. Nearsightedness folks have a focal length lens that's too short. As a result, the image they produce is out in front of the retina. It's too short a distance. It doesn't fully span the diameter of the eye. By the time the light actually reaches the retina, it's back again out of focus because the rays have started to diverge. Such individuals have to hold objects closer to them, making p smaller, the p being the object distance, and that increases the image distance because remember 1 over I plus 1 over p equals 1 over f. And when p gets smaller, the 1 over p term gets bigger, and that makes the 1 over I term have to get smaller, or I gets bigger. So they're compensating for that short focal length by just forcing I to get larger. Folks who are farsighted have somewhat the opposite situation. These folks have a focal length lens that's too long, and the image that they produce is after or behind the retina. It takes too long for the light rays to converge. By the time the light actually reaches the retina, it's still out of focus because it hasn't even converged yet. Such individuals often have to hold objects far away from them, making p larger, and thinking back to 1 over I plus 1 over p equals 1 over f, when p is larger, 1 over p is smaller, and that makes the 1 over I term get bigger, or I becomes shorter. That way they're able to reduce the image distance I such that it actually equals the eye's diameter. Now, of course, you and I know that many times we can see objects at different distances, and yet we're not focusing like a camera does. Unlike a camera, you don't actually move the lens of your eye. You always have a lens located at the same location relative to your retina. And so you always need the image distance I to equal the diameter of your eyeball. So you don't get to vary things in the same way a camera does. Now we know that things that are very distant from us are coming in have light rays that are coming into our eye nearly parallel and don't need much refraction to bring them into focus. Objects which are close to us, however, the light rays from those things are diverging quite a bit and need quite a bit more refraction for focusing. That's again just thinking back to that 1 over p plus 1 over I equals 1 over f equation. When p gets smaller, then we need to have something happen in order to have I be the same thing, and that is that f has to get smaller. To achieve this, your eye actually changes the focal length of the lens muscles and can adjust the lens focal length to create a sharp image for different object distances. The eye adjusts the focal length by tightening or relaxing the ciliary muscles, thus allowing the lens to become more or less curved. So here's an example of your lens of your eye, where the ciliary muscles are relaxed, the fibers are taut, pulling the lens outward and creating a somewhat less rounded lens. Here the ciliary muscles are contracted, the fibers go slack, and the lens rounds somewhat to create a greater strength for close vision. The focal length essentially shrinks. So our eyes are like a camera, except that what it is that we manipulate is the opposite of a camera. We manipulate focal length in our eye, whereas in a camera, you tend to manipulate lens to film distance.